Hello and welcome to this presentation on the simple properties of vectors. Vectors are quantities that have both magnitude and direction. Some vector quantities include displacement, velocity, acceleration, force, electric current, etc., etc. Scalar quantities, on the other hand, have only magnitude or a number sum. Scalars include such quantities as length, mass, distance, time, etc., etc. Vector quantities can often be identified by bold type with an arrow above the symbol. The vector velocity is equal to 23 meters per second northeast. Northeast is the direction, 23 is the magnitude. Vectors are graphically represented by drawing simple arrows. The length and direction of a vector should be drawn to a reasonable scale size to show its magnitude. 10 kilometers to the east should be half the size as 20 kilometers to the east, or 20 kilometers to the east should be twice the size of 10 kilometers to the east. Here we see two vectors drawn, each represented by an arrow pointing in a different direction. Vector A has been drawn 6 units long and is pointing to the right, commonly referring to the east. Here you can notice that vector A and vector B are identical. They're both the same length as drawn, and they both point in the same direction. These vectors are not identical. They are neither the same length nor the same direction. Now let's see how we might find the vector sum while adding vector A to vector B. When vectors are added together, they should be drawn head to tail to determine the resultant, or the sum of the vectors being added. The resultant vector should be drawn from the tail of vector A to the head of vector B. When drawn to scale, the resultant, vector C, can be found graphically simply by measuring the length of the arrow. The resultant vector can also be found mathematically in right triangles using the Pythagorean theorem. Side C squared is equal to side A squared plus side B squared. Now let's learn about negative vectors or subtracting vectors. The negative of vector A is a vector of the same length but pointing in the opposite direction. How might we find the value of vector A minus vector B? Our resultant vector C is equal to vector A plus a negative vector B. So in other words, vector A minus vector B is the same or equal to vector A plus a negative vector B, which equals our resultant vector C. The resultant vector can also be found mathematically in non-right triangles using the law of cosines. The law of cosine states that the resultant side, C squared, is equal to the side A squared plus the side B squared minus 2 times side A times side B multiplied by the cosine of the angle theta. What might be the resultant vector of 2 times vector A? The resulting vector would be twice as long and in the same direction. A single vector at an angle can also be broken down into components to find its x and y coordinates. All you need to do to find the x and y components of vector B is to simply construct a parallelogram along the x and y coordinates. The x component of vector B lies along the x-axis, and the y component of vector B lies along the y-axis. The sides of this parallelogram can also be used to form right triangles. And therefore, the sides of the right triangles can be determined using the equation where the vector b squared is equal to the component bx squared plus the component by squared. The angle at which a vector is above the x-axis, known as the angle theta, can also be determined using simple trigonometry. SOHCAHTOA, which stands for the sine of angle theta is equal to the opposite side divided by the hypotenuse, or the cosine of angle theta is equal to the adjacent side divided by the hypotenuse, or the tangent of angle theta is equal to the opposite side divided by the adjacent side. These simple trig functions can now be used to find the components of vector B. The x component of vector B is equal to vector B times the cosine of angle theta, or you can find the angle theta by using the cosine of angle theta is equal to the x component of vector B divided by vector B, and the y component of vector B is equal to vector B times the sine of theta, or you can find the angle theta by using the sine of angle theta is equal to the y component of vector B divided by vector B.